Welcome back. Before we actually get started on learning to do SN2, SN1, E1, and E2, okay? It's not so much the mechanism or being able to do something very little is of any importance. It's actually understanding the chemistry behind it, which is why so far I've not even taught you what this SN2 or SN1 is or what does it look like. But I have set you up through my introductory video every basic or information that you need to know, which would make more sense as you do the actual reactions. So in lieu of that premises, I do want to take the time to see if you've paid attention to all the key words I mentioned in my introductory video. My introductory video is all you really need if you really want to have a good grasp on the idea of substitution and elimination reaction. Like I said, doing the actual reaction itself is not such a big deal, but to be able to understand the three components, that is a nucleophile, substrate, and the leaving group, and how do they influence, basically how does it influence a particular substitution or elimination reaction is fascinating. So let's start with some formative assessment, quick pop type quiz assignments. Now you're welcome to, after I give you the question, and you're welcome to pause the video and then try to solve it based on just, again, you would need to be an organic chemist to be able to do this. If you watched the introductory video at least twice, you should be able to do it. Okay, this is how I see the exam questions shaping up. Anyways, with that said, so the first formative assessment question is, circle and identify the carbon in the substrate containing the leaving group in each of the compounds shown below as metal, primary, secondary, or tertiary. Now keep in mind, I said there could be thousands of carbons in a compound, but the carbon that we focus on is the carbon that contains the leaving group. So I have 4 sets of compounds here, and your job is to circle the compound, circle the carbon that contains the leaving group, and also identify whether that carbon substrate, that particular carbon is the substrate that contains the leaving group. Is it metal, primary, secondary, or tertiary? Right? You can go ahead and pause the video at this point, and if it's metal, write M. If it's primary, write P. If it's secondary, write S. Or if it's tertiary, write T. Okay? So again, you're focusing only on the carbon that contains the leaving group. Okay? That whole thing is called a substrate, right? Not the leaving group, but anything but the leaving group is a substrate. So I will go ahead and pause and try to solve it. So I'm going to pause. You can go ahead and pause the video now. All right, provided you have worked it out and you have the answers with you, let's see if you got them right. Okay. All right, this carbon that contains the leaving group, okay, it contains only 1 hydrogen, right? Because it contains 3 bonds. That means the 4th bond has to be hydrogen. So a carbon substrate that contains the leaving group, if it contains 1 hydrogen, is secondary. This is also secondary because it's no different than the first compound. It just looks different. This compound number 3 is metal, right? Because it's only 1 carbon, and it's. Remember, I've always said that whenever you have a bond that is open or loose, that it has to be a CH3. So it contains 3 hydrogens attached to a leaving group. So that's metal. And this is number 4, so that would mean that carbon would contain no hydrogens. That means it also contains the leaving group, which is right here. So that means that would be a tertiary carbon substrate, right? Moving on. So second question, if each of the compounds shown below were to undergo nucleophilic substitution, would you expect an SN2 or SN1? Okay. Now, I'm going to move this up so you can read it without any problems. All right. So you have 4 compounds. It's exactly the same 4 compounds that we had in the previous question. So you can go ahead and pause the video. Now, the knowledge you need to solve this question is based on that little arrow thing that I had. And if you determine your carbon substrate to be primary, methyl, or secondary, then they usually undergo an SN2 substitution reaction. And if your carbon substrate is tertiary, then it typically undergoes SN1. Now, I've already given you the answer in a way, so you can go ahead and pause the video and write SN2 or SN1 next to each compound. So that's a secondary, so SN2, secondary SN2, methyl SN2, that's a tertiary, so that's an SN1. See how easy that is? So this is how they test you on a lot of the standardized exam outside of my class. Formative assessment 1. So I got another question for you. If each of the compounds shown below were to react with OH minus, which is the nucleophile, what is the rate law of each reaction? Basically, what I want you to do is take each of the compound, which is your substrate or your reactant, which contains a substrate and the leaving group. You add plus OH minus, which is your nucleophile, and then based on your knowledge of whether it's an SN2 or SN1 from the previous question, you would be able to write the rate law. Now, I am not going to write for all 4 of them. I'm going to write for 1 of them, and you are welcome to write the remaining 3 as you come back. As you pause the video and then you play it, you will see just answer for 1 of the compounds, because I don't want to just write the remaining 3 because it's kind of not that much different. You just have to practice. So go ahead and pause the video and then come back to it. All right, provided you pause the video and you've written the rate law. So the rate law for this would be, unfortunately, I didn't have the time to, make the 13 and the 6 as a subscript. But what I did is I counted all the carbons. So there's 6 carbons total, and there's 13 hydrogens, and then a Cl. So that's my whole reactant. You may want to write it this way. Because you can write the structure itself, but I don't think that is something I can do in PowerPoint. So just count the number of carbons, number of hydrogens, and Cl. So that's one of your reactant, and your nucleophile OH minus goes in here. Now, why did I write it as a second order rate law? Because I know this is an SN2, right? Because we determined this is a secondary carbon substrate, so it will undergo SN2. SN2 is a second order reaction, means it depends on concentration of both the reactant and the incoming nucleophile. So you can do the similar for the remaining ones, provided you know from the previous question which ones are SN2 and which ones are SN1. Okay, rank the leaving group in each of the compounds shown below in the order of increasing tendency to leave. That is a higher efficiency to leave. That, as we mentioned earlier, I'm going to move this up. Okay, so you have 4 compounds, each containing a carbon that's attached to a leaving group. In this case, the first one is Cl, the second one is Br, the third one is OH, and the fourth one is OTS. That's a tosylate ion, right? Now I want you to rank them in the order of increasing tendency to leave. That is, you want to go from the group that have the least tendency to leave to the group that has the higher tendency to leave. You can go ahead and pause the video at this time and recoup your knowledge from video 1, and then see if you can rank them, and then continue to watch the video to find the answer to the problem. As we see, OH is the group that has the least tendency to leave, and then you have your Cl, and your Br, and then you have your OTS. What do you see is common without, say you do not have to remember this knowledge of which one is a bigger group. The bigger the size of the group itself, the higher the tendency for it to leave. Now, OH, the molar mass is about 17, chlorine is about 35, bromine is about 79, and tosylate is definitely a huge, huge molecule. So putting it all that together, it just makes sense. The bigger the leaving group, the higher its efficiency to leave, right? All right, so this is the formative assessment video where I want to just capture, because it's immediate, right? Now, if you didn't understand the first video, I don't think you would be able to answer any of these questions to the you wouldn't be able to answer any of the 4 questions presented in the video. So in the next 2 videos, I'm going to split it as one video for substitution reactions and another video for elimination reactions. So that'll be the 4 videos you will need to get started on the topic of substitution and elimination reactions. So stay tuned.